The simulation and analysis of pipes made from various materials, such as steel, aluminum, concrete, and composite materials, play a vital role in modern engineering design, infrastructure development, and industrial applications. By using advanced finite element analysis (FEA) tools like Abaqus, engineers can accurately model, simulate, and predict the behavior of pipes under diverse loading and environmental conditions. Pipes are fundamental components in transportation systems for fluids, gases, and slurries, as well as in structural applications such as bridges, tunnels, and offshore platforms. Each material type exhibits unique mechanical properties and performance characteristics. Steel pipes offer high strength, ductility, and durability, making them ideal for high-pressure and structural applications. Aluminum pipes are lightweight and corrosion-resistant, suitable for aerospace, marine, and lightweight industrial systems. Concrete pipes provide rigidity and longevity in civil and infrastructure projects, such as water conveyance and sewage systems. Composite pipes combine materials, e.g., fiber-reinforced polymers, to achieve a balance of strength, corrosion resistance, and reduced weight. Using Abaqus pipes package, engineers can simulate static and dynamic loading conditions, internal and external pressure effects, thermal expansion and contraction, fluid structure interaction, buckling, fatigue, and failure modes. Through such simulations, design optimization and performance verification can be achieved before physical prototyping, leading to cost savings, improved safety, and enhanced efficiency. The results enable informed decisions in selecting suitable materials, pipe dimensions, and joining methods for specific engineering applications. This package provides a comprehensive course on pipe simulation using Abaqus software. It includes 21 detailed and independent projects, each supported by research-based models. Every project offers step-by-step guidance through English language videos, CAE INP files, codes, and accompanying research papers. The course covers various pipe types: steel, concrete, aluminum, and composites, as well as advanced material models such as concrete damaged plasticity (CDP), Johnson-Cook hardening and damage, ductile damage, Hashin's criterion, time-dependent materials, JWL, and Mohr-Coulomb. The analyses encompass seismic and cyclic loading, low and high velocity impacts, bending, flexure, explosion, failure, fracture, corrosion, welding, and creep. The package includes 21 practical and comprehensive tutorials, each of which is described in detail on the course description page. FEM provides a powerful and flexible framework for realistically analyzing and simulating concrete structures. By capturing material nonlinearity, cracking behavior, and complex geometries, engineers can predict performance, optimize design, and ensure safety and reliability. This package is ideal for civil engineering students, geotechnical specialists, and researchers. With lifetime access to downloadable resources, you can learn at your own pace anytime and anywhere. I hope you have a good understanding of this package, but for more questions and details on each section, please visit our website Engineering Downloads or email us at info@engineeringdownloads.com.